Hi everybody, here's the notes for today, Wednesday, August 12th, section 1.3J1. When you walk upstairs, there's a certain steepness to them. The steepness can be calculated by using the term slope. Slope is a numerical measure of the steepness of a line and can be found as follows. Here's the definition. Let P equals x1, y1 and Q equals x2, y2 be two distinct points. If x1 is not equal to x2, if the x's are different, then the slope of the non-vertical line containing P and Q is defined by the formula. Write the slope formula. You should know what the slope formula is, how to find the slope between 2 points, x1, y1 and x2, y2. It's y2 minus y1 over x2 minus x1. x1 can't be equal to x2 because what would happen if x2 and x1 were the same? What would you get in the denominator? You would get 0, and it would be a vertical line and the slope would be undefined because you can't divide by 0, because slope is this formula, y2 minus y1 over x2 minus x1, which is rise over run. How much the graph rises goes up, and then how much it runs to the right. Does this slope run? Does it move to the right or to the left? It's the change in y, how much the y changes between the 2 points, and then how much the x changes. And these deltas, these triangles, means change in y over change in x. So here are some lines below. From the bold line, which is right here, draw a vertical line up to each line. This demonstrates, so from here to here is this long, and from here to here to this line is that long. That's the rise. The rise from this horizontal to here, or the rise all the way up to here. And this part, that's the run. This demonstrates that for the same run, because they both go from this point to here or here, it's the same run. The line A, this is an A right here, it's a tiny little A, and line B. Line A has a larger rise than line B, so the steeper, it's steeper, right? So the steeper the line, the larger the slope. So if the line is really steep, like this, then it has a big slope. If the line is kind of flatter like this, then it has less slope. It's just less slope. Find and interpret the slope of a line that passes points 1, 2, and 3, 6. Does it matter which point is x1, y1 and x2, y2? Well, let's find out. The slope is y2 minus y1 over x2 minus x1. I usually have the second point be x2, y2 and the first one be x1, y1, but we'll see if it matters. So 6 minus 2 over 3 minus 1, change in y over change in x equals 4 over 2, which is 2. Now if we do it in the other order, and we do this y minus this y, 2 minus 6 over this x minus this x, 1 minus 3, we get negative 4 over negative 2. The negatives cancel and we still get 2. So the answer is no. So either way you want to find the slope, it doesn't matter which point comes first, as long as the 6 and 3 stay together because they're from the same point, and the 1 and 2 stay together because they're from the same point. So we're going to find the slopes of these lines. P1 is, line 1 is 2, -1, 2, -1 to 4, 3. I have a ruler, and that's L1, and the slope 3 minus -1 over 4 minus 2 equals 4 over 2, which is 2. Line 2 is 4 minus -1 over -1 minus 2, which is 4 plus 1, because minus and minus is a plus, right? That's what happened here. Over -3, -5/3. So we'll do that one in purple. 2, -1 starts here, and it goes to -1, 4. And the slope is -5/3. That's line 2. Line 3, the slope is 5 minus -1 over 2 minus 2. 5 plus 1 over 0, 6 over 0. What happens when we get a 0 in the denominator? It's undefined, can't divide by 0. So we start at -2, 2, -1, and we go to 2, 5. And it's a vertical line, and it's line 3. And then my last line is slope is -1 minus -1 over 8 minus 2, which gives us -1 plus 1 over 6 equals 0 over 6, which is 0. And we start at 2, -1, and we go to 8, -1, which is right here. They all go through the same point, 2, -1. This is line 4. So those are the 4 lines. And what this illustrates is when the slope of a line is positive, like in A, line 1, the line slants upward from left to right. Right? It's going upward from the left to the right. It's going upward. If the slope of a line is 0, that was this one, what kind of line is it? Horizontal. If the slope of a line is negative, like B, line 2, then it, instead of going upward, it's downward from the left to the right. And the last one is if it's undefined, then we know that it's vertical. So draw the graph of the line that starts at -1, 2, and it has a slope of 2. So the slope is 2, which is 2 over 1, which is right 2, up 2, right 1. So you go up 2, right 1, up 2, right 1, down 2, left 1, and draw the line. And the other line has a slope of negative 4/3, so it goes, it's negative. Down 4, right 3. So we start at this point and we go 1, 2, 3, 4. There it is. Down 4, right 3. We always go to the right. Down 4, right 3. And use the ruler. Down 4, right 3. It's either up or down, and there's always to the right. And there's our line. So we're going to find the slope of we're going to find the equations of a vertical and horizontal line. So if we put in negative 4, because it says x equals negative 4, if you put in negative 4 and then negative 2, you get negative 4, negative 2, which is negative 4, negative 2, which is right here. This is negative 4, negative 1, negative 4, negative 1. This is negative 4, 0, right there. This is negative 4, 1, right there. And negative 4, 2, right there. What kind of line is that? Vertical, and it's x equal. So if it's a vertical line, then it's going to be x equals a, where a is the x-intercept. A is negative 4, and that's where it intercepts the x-axis. So it's x equals a. You can do the same thing with y equals 2. If we put 2 in for all the y's, then we get negative 2, 2, negative 1, 2, 0, 2, 1, 2, and 2, 2. So negative 2, 2, negative 1, 2, 0, 2, 1, 2, and 2, 2. What kind of line is that? And it's horizontal, and it's y equals 2. So it's y equals b, where b is the horizontal line, and b is the y-intercept, and x is the x-intercept. A is the x-intercept. So we only have a little bit more, but I'm going to stop this video and start the next one.